Hi, Dave.
Hi, Brendan. How you going?
Good. Are you okay to introduce Alfons and do a little bit there? Is that all right?
Yeah, sure. Yeah, that's fine.
Great. I thought just as the sponsor, and it
Yeah.
brings credence with your position, and then pulling that in, so that'll be good.
All right.
I've also added Alfons' slides because he said he might have problems moving it, but I just need to work out how I actually enable that. Give me a second. I'll try and set that up. Share. It's always harder than you think it is.
Alfons.
Dave, how are you?
I'm really good. How are you?
Good, good. Let me just get. All right.
Doesn't seem like that long since we were together. Much longer, much shorter than our normal gaps.
I know. Yes. Did you get your golf game in yesterday or the other day?
Wednesday. Was a big storm in Perth, so no, I didn't.
Oh.
We had lightning and thunder and very, very high winds.
Wow.
Mm.
That's kind of unusual, isn't it?
Yeah, it was. It was a bit unique.
I'm going to figure out how to share. Let's see.
Alfons, do you want me to share as we go through, or you want to share from your end?
It's probably better if Alfons can do it if it works.
Yeah, I'll see if I can.
We got Graham driving.
Yeah, I'm just coming back from Griffith, actually.
Okay.
I was with the northern panel there.
Complete with indicator noises too, I noticed. So.
Oh, that's what it was.
Yeah, I'll mute.
Oh, here we go. So Brendan, I should have practiced this with before, but in terms of sharing the screen, I go to share and then window.
Then there'll be options for your screen, and you should see a PowerPoint if you've got it open.
I don't. I've got it open.
Screen will work. Just choose the main screen.
So if will you see that?
Not yet.
We need permission to share your screen. Give permission to start.
You're added as a presenter. Just restart. Just close that share button. So click the share button, and then go again. You should have permissions.
Okay.
Is your share button sort of grayed out, Alfons, or is it?
Yeah, it is.
Okay. That's not going to work then.
Just wait. I think I got it.
Ah, yeah, there we go. We're good.
No, that's me. If you can get it, Alfons, you go.
Oh, right. That was you sharing, Brendan. Okay.
I've got it on, but I have to quit Teams and come back. Why don't we just we won't bother with that. I'll rely on Brendan.
Yeah. So Brendan, do you have the presentation? Yes. Okay. Cool.
Great. All right. Thanks. I think we've already got a fair few on the call. So thanks everybody for joining, and Alfons for agreeing to present. And I'll actually hand over to Dave Pannell as the sponsor, suggester of this, and the connectivity that got us to this point. So Dave, over to you to introduce.
Okay, thanks, Brendan. I'll just do a brief introduction of Alfons. Alfons is one of Canada's leading agricultural economists. And if I think about the various agricultural economists in Canada, Alfons is probably, or I think definitely, the one with the best fit for the sort of issues that we're interested in this project. He's like a farming systems, farm management person, but also with plenty of crossover into other areas around agriculture as well. I've known Alfons for 25 years or something. He first met him when he came to a conference here in Australia, and we've had good connections and some collaborations ever since. And the paper that I've suggested that he present is fairly old, but it's so closely connected with what we will be doing in our project that it seemed like a good option for him to talk about. But there is one specific difference between the context in Australia and the context for the paper that Alfons will present, which is that within our project, there's sort of a perception that Australian farmers are perhaps underutilising nitrogen fertiliser, whereas the context for Alfons' paper was a perception that Canadian and North American farmers were overusing nitrogen fertiliser. So that's a difference that maybe we'll come back to in the discussion. Mm-hmm. So I'll hand it over to you, Alfons. So take it away.
Yeah, thanks, Dave. This excuse me, though this paper is a bit old, it is very relevant to me right now. For those of you who might be aware, Canada has made this policy that they're going to try to reduce nitrogen emissions from fertilizer use associated with crop production. It's the only greenhouse gas emission policy that targeted towards agriculture. And again, they're trying to reduce nitrous oxide emissions from the use of fertilizer. And this policy went over like a lead balloon. Bit surprising, because Dave has a nice paper that looks at sort of categorizes environmental policy as it relates to agriculture, and typically incentives have been used and education programs to get farmers to move from where they are to something better. There are sticks used to prevent them from going backwards, but if you're going to, just for a number of political reasons, the nature of the environmental problems associated with agriculture, that it tends to be carrots instead that are used. And it was a voluntary cost share program, very typical, but it got hijacked for a number of reasons. Got associated with the nitrogen policy that was implemented in the Netherlands, where they were going to close farms down, livestock farms, and it became a very political issue. Anyhow, it seems to have settled down, but the idea that we're going to try to reduce greenhouse gas emissions from agriculture, largely through changes in fertilizer management, is like the hot topic in environmental issues related to agriculture now. And as Dave mentioned, let's see. Well, yeah, it's an older paper, but this is one that I think plays a role in how we're looking at this. Because if we're going to try to have an effective policy, we have to understand what drives producer behavior. So I know risk is the emphasis of your particular theme initiative, and we'll see that risk is pretty important, but I don't think plays much of a role in terms of the actual application decisions. Okay, so Brennan, could you move ahead? Thanks. So why do farmers apply at rates different than recommended? And as Dave mentioned, that for corn production, they're probably typically we're looking at 200 kilograms of nitrogen per hectare to give you an idea of the typical amount that's applied. And farmers tend to apply more than that. And it's been documented in the States in a number of examples and a few cases in Europe. And it's more anecdotal here. So why might that be the case? Well, one is that farmers think that these recommendations aren't appropriate for their situation. It's based on some general location within the region, but theirs is different for some reason. I think this is a big one. There's differences in perception on how crops respond to fertilizer. That many farmers think that there is a pretty still significant marginal product is pretty high near the optimum and near the maximum yield. That if they apply a bit more, they're going to get a pretty big bang for their yield, and if they apply less, they could really suffer. These recommendations are many jurisdictions have a spreadsheet that's online that you put in what the prices are, what crop you grew beforehand, and something about the yield potential. And I think a lot of farmers overstate the yield potential of where they're located. Next one, Brennan. I think this is one, the fourth, the idea of time constraints at planting time, that there's a limited amount of time to do things, and they will apply fertilizer in bulk before they plant and broadcast, and they just want to get as much down as they can before things really get busy. So I think that has an effect. There are behavioral factors, and as I will talk about more, I think this importance is really magnified by the idea that the payoff function is very flat for fertilizer. And finally, there's the uncertainty with yield response to application. So these farmers have to make these decisions about how much fertilizer to apply well in advance of what they know the growing season is going to be like. And as I'll show you, there's quite a difference in the temporal variation. So why the concern if more is applied? Well, I have just sort of the top graph is the good production function. We've got nitrogen rate along the x-axis, and we've got corn yield along the y-axis, and we've got this increasing rate, and then it slows down, and in this case, it sort of reaches a plateau, doesn't come down. In the bottom part of this slide is a production function for a bad output, and it's nitrogen emissions. It could be nitrous oxide into the air, it could be nitrates into the water, and you'll see it's fairly low until we hit a point where the plant is not taking up any more nitrogen. And then where does it go? It goes up in the air or it goes down in the water. So, so we're not really concerned if the farmers apply too much. That's their decision. And if it means that their profits are a bit lower, then so what? But we've got this public impact of their decisions, this negative externality. And as you see, a little bit above the optimal can lead to pretty significant implications for greenhouse gas emissions. Next slide, Brendan. So I know you're focusing on one paper, but this student, Predrag Rajic, he did 2 papers for his master's thesis, and the first was looking at a number of different sites, well, only 7 sites over multiple years, and trying to determine whether the ex-post optimal nitrogen rate. So we know after the harvest season's done, the trials that were in place, that we can estimate a response function, and we can come up with what is the optimal rate. And I'll call that the MERN rate, the maximum economic rate of nitrogen. The agronomists tend to use that. So what this particular paper does is it looks at the MERN rate and compares it to the recommended rate. And so we look at a couple different things that might contribute to why farmers over apply. One is maybe it's the functional form. Maybe it's that the response is different depending on what functional form is used, and that might represent one farmer versus what is used by the extension agents in terms of generating recommendations. Well, we find that there's no statistical difference in fit. There is a variation in the MERN amongst the functional forms, so maybe there might be some impact. But if we look at profitability, it doesn't really make too much difference. In terms of site, the recommended rate is lower than the economically optimal on low productivity sites. So there is a situation where maybe this is what you're finding, that that the recommended rate is less than what is found to be optimal ex post. The big thing that comes out of this study is a significant variation in the MERN rate across years, significant temporal variation. And the other point is that within a given year, the payoff function is very flat. Next slide, please. Okay, so this is not from that study, but it is from some colleagues who are agronomists at the University of Guelph. And what we have here are the response functions for about 10 years. And this, they calculate, so we've got the yield response function, and the star on each of these response functions represents the optimal nitrogen rate. So that is where the marginal product of, or the slope of that response function is equal to the price ratio, the ratio of the nitrogen price to the corn price. So what you see is that there's a great deal of variation in the optimal N rate across these approximate 10 years. So it goes from 140 kilograms of nitrogen per hectare to 260. And this is the same soil, same management, same hybrid, everything is the same except the growing conditions of the year. So significant temporal variability. Next slide, please, Brennan. This one is a little more difficult to see, but for these same years, we calculated the payoff function, and the green. So each line is a payoff function. The star or the X represents the maximum payoff and the associated nitrogen rate. So again, you can see that in the bottom one, 140 kilograms of nitrogen, to the far one, 260. The green represents if you decreased the nitrogen applied by 30 kilograms or increased it by 30 kilograms per hectare, what would happen to profits? And it almost, in all cases, you get within 10 kilograms of the maximum profits per hectare. So again, what Dave has found in a number of situations, and this is another example, the payoff function to nitrogen is very flat around the optimal. And so the 2 points that I want to highlight coming out of this particular paper that leads to the other one is the temporal variation, that yes, indeed, there's a lot of uncertainty. You know, the farmer's deciding, do I apply 140 this spring or do I apply 260? You know, a significant increase. The second is that within the year, it doesn't really matter that much. So if they knew ahead of time that it's going to be 140 would have been in the optimal, it doesn't really matter if they apply 110 or 180. The returns are going to be pretty similar. The big thing is if they had any idea what the growing conditions were going to be like. Okay, next slide, please, Brennan. So this is a paper that you've been asked to look at or to discuss, and this looks at the effect of temporal uncertainty on the MERN rates compared to the recommended rate for both risk neutral and risk averse producers. So next slide. So what's the effect of yield uncertainty? And we'll look at it in the terms of risk neutral producers and risk averse producers. So a risk neutral producer, they still consider uncertainty, but it's expected profits that they are looking at. And expected profits are weighted by the probability of the occurrence of the random event. So it's not just summing these up equally, you know, somehow you have to weight these expected profits. And a number of farmers will say this, that they apply a little extra just in case. And that notion is justified if the profit gain from the boost in yield that you get in good years is greater than the decline in profit in the bad years. So what you're doing is comparing the cost of over application to the cost of under application, and which, you know, is it justified? It depends on the skewness of the returns over time. So do you get a big boost relative to, in those good years, that offset the costs of over application in the other years? So what do we find? That the profit from applying more than the recommended is actually less than if you applied the recommended for more years. So again, we're comparing, you know, if the recommended is 175, what happens if you apply more? Generally, you're going to lose a little bit. But when the conditions are right, there's a big boost in extra profits from applying more than the recommended, and it's sufficient to result in a small increase in overall profit, something about a 14%. And the other point is that if you apply significantly less, let's say 50% less, results in a reduction in profit of 75%. In contrast, if you apply 50% more than the recommended, you get a 20% reduction in profits. So the relative impact of applying less than applying more has an impact on profits. So what about on a risk averse producer? So this is like the utility of returns, and as a result, you have to have some idea about their risk aversion, their risk attitudes. Risk averse producers want to reduce the variance of returns, and given that assumption, it depends if nitrogen is a risk increasing input or if it's risk decreasing. So risk increasing means that if you apply more, the variability of returns increases. And if that's the case, then risk-averse farmers don't want to apply too much. On the other hand, if it reduces risk, then they are going to apply more of that input because the variability of the returns are lowered. There is a potential that maybe what fertilizer does is it reduces the downside risk, so that if you've got these poor growing conditions, maybe by applying more, you reduce the probability of low yield. And then indeed, fertilizer could be considered as an insurance mechanism. So next one. So what do we find? One is that nitrogen is a risk increasing input, that the variability of returns does increase. If we look at the recommended rate compared to the different types of, significantly less or significantly more, the recommended rate tends to be first degree stochastic dominant. So in other words, for most, the probability of the returns are greater for the recommended rate. There's a small difference in N between risk neutral and highly risk averse producers if we use a certainty equivalent maximum model. So in other words, risk aversion has very little impact on what the optimal nitrogen rate would be. If we look at risk value functions, higher N rate increases profit, shortfall variance, but again, it has a minimal impact. So to summarize, risk does have an impact on expected profits and this temporal variation. And its impact depends on the skewness of those returns. If those returns are normally distributed, you're equally likely to get higher and lower returns from applying different than the recommended, then it balances out. We find that there is this bump that occurs. The other thing that I mentioned is related to that first paper is the idea of this flat payoff function, that varying the N rate within the vicinity of the optimum doesn't make a big difference. This is a quote that Dave has used before from Jock Anderson, and it's so Jock, right? Optimal levels of decision variables, precision is pretense, and great accuracy is absurdity. And I think this has implications for variable rate technology, but that's another story. But what it does mean is that since the returns are there's little difference in returns around that optimal, that it means that there can be a number of other factors can influence the nitrogen rate. The intrinsic value of a good-looking crop. I don't think this can be understated. You know, for us, it hurts farmers. We had a dry year last year, and it hurt farmers to look at those crops. There's a network effect of what other farmers do. There are environmental stewardship considerations that influence what farmers do. So to conclude, the effect of N on crop yield is unknown at the time of application. So yes, indeed, there's uncertainty in the yield response, and that does have an implication for fertilizer management. It does increase N for risk-neutral farmers if the expected profit of doing so is greater than with the recommended rate, and we find some support for that. For risk-averse farmers, N is a risk-increasing input, so they should apply less, but the impact is very limited. And again, to conclude with what is motivating the rejuvenation of this study is that we're looking at how can they design effective policies in order to reduce nitrous oxide emissions from crop production. And it really requires understanding how farmers make decisions with regards to fertilizer, and it's complicated. And so with that, I'll end here and then take some questions.
Fantastic. Thanks, Alfons. So feel free to raise hands if you'd like to ask a question or to put something in the chat. And to kick it off, I see that Lindsay has put something in the chat. So let's start with that and then we'll go to Graham. So Lindsay says, but most risk-averse farmers are more worried about lower end variability. So how does this look if we just consider the downside risk?
Yeah, this profit shortfall looks at some of that, and not in the same way. I think there's something like prospect theory would be a good approach too. You know, where in terms of an absolute value, a loss hurts more than a gain. So you want to prevent that loss, and I think there's something to that. And maybe to give you a sense, there's an agronomist who is very popular in Ontario, and old-time extension guy who has and had a fairly big consulting business. And he said the only client he lost over his extended number of years was a farmer who he told to reduce the amount of nitrogen he was applying, and the farmer didn't want to listen to it. And he said, because that I'm afraid of this downside impact. I want to apply sufficient to avoid that. So, yeah, Lindsay, I think we haven't accurately looked, we haven't sufficiently looked at that. But that's part of this, what they refer to as an insurance mechanism, farmers, and it does play a role.
I thought that you were picking that up largely in your insurance part of the analysis.
Yeah, I don't think we did that great a job with it, Dave. I think that there's some other aspects that we, looking back at it. Yeah, I thought we did a better job than we did. So maybe.
Okay.
Yeah.
Can I follow up, Dave, just quickly before we change? So, Alfons, how do you think we should weight that? If we were analysing a similar way, the same sort of things that you're looking at here, how do you think we could weight that downside risk relative to risk aversion, and how would you think that could be done in the same context as yours here?
Yeah. Well, yeah, I'm going to sort of, I don't know whether, I really don't think downside risk is all that big a deal. Like, I think the, if you look at the risk aversion aspects as a total, it has minimal impact. I think there are other factors that play a more important role. And I think one of the things we're looking at doing, and this is jumping ahead, maybe something else, but I think it does fall into this discussion, is I think we're going to try to take a look at what farmers think is the impact if they reduce their nitrogen use by 10%, by 20%, by 30%, and similarly if they increased it by that level. And I think there'd be real value if farmers could get paid to do strips in their own field where they could be covered for that, and say, and it's easy enough for them to do, and now with yield monitors, very easy for them to determine the effect. And I think they would be surprised at that yield doesn't decrease that much with reducing N rates. Or, and maybe you could do the same thing in Australia by saying, what if you applied more? We're going to pay you some more to a strip where you do apply more than the recommended.
Okay, thanks, Alfons. Just to clarify, when Alfons has modelled risk aversion, then built into that is a higher weight for downside risk than upside risk. That is what risk aversion means.
Yes.
It's done in a different way in different theories. He mentioned prospect theory as a different version, but in both cases, there's a higher weight on downside risk.
Yeah.
Okay, let's go to Graham. You're muted, Graham.
Brendan, could you please share the PowerPoint and go to, I think it's the graphs showing the data where we've got nitrogen response with different years at the same site. Alfons, I've got 3 questions about this graph, and they more relate to the Australian context, and I'll just wait for it to come up if we could. The first is that some of our cropping systems, yeah, that's it there.
I think it might be the next one, the one back, Brendan. I think that's
no. That's fine. That's fine. So, in some of our cropping systems, we'll come out of a pasture phase into a cropping phase.
Yeah.
And what will happen is that at about on the y-axis, say between 10 and 12, that's the 0 rate response, right? So that's an additional set of data to what you presented here. So we can have country that's been cropped for a long time where they do start low, and there's this response of you've articulated here and shown here. There is also a percentage of our country that actually coming out of pasture does potentially start high on the y-axis.
Yeah.
So that's an addition to this. The other is that there is, in Australia, the flat line that you've shown here, we can definitely curve over. And I personally have a really good data set that shows that curve over. So where we reduce yield with higher input of nitrogen.
Yeah.
So that's point 1 and 2 that I'll get you to talk about in a minute. And point 3 is that here I'm contrasting your top yields and your bottom yields. And in the Australian system, what can happen over a 10-year period, you make 70 to 80% of your money in 3 out of 10 years. So when you bring all of those things together, if you think about that, it's possibly adding a bit of a riskier situation when you bring all those 3 points together. It's bringing a a riskier situation than this graph and its further analysis would permit. Any comments?
Yeah. So first of all, like you're looking at fertilizer applied to wheat. To what is it that you're? What's the crop that wheat? Okay. Yeah. And so the first point that the level of what happens if you don't apply any fertilizer, so where it crosses the y-axis at 0. Yeah, that's this particular site is with a long-term corn on corn, so it doesn't have which is atypical. Now corn was kind of the dominant, and now it's corn, soybeans, and they'll grow wheat and with a cover crop, and then corn would come back on. And so that sort of system would have that boost in yield at the y-axis that you're talking about, switching from pasture. I think, let's see, I do think that what you've mentioned, I think explains a lot. I think going back to for a risk neutral farmer, the expected returns, with the weight, if you say you get that you get profitability in 3 out of 10 years, then that means, and you've got potential for crop failure. And I think that does influence it. In contrast, one of the I think unique things about where we are in Canada, we are in the midst of the Great Lakes. We've got Lake Huron on one side, Lake Erie on the other. We have a very moderate climate. We've never really had significant crop failures here. So even though it looks like there's significant variability in yields over time, we don't have that sort of variation that you, and I think that can, I was wondering what might be the reason for the difference in Australia versus, let's say, North American corn farmers. And I think it's got to be that probability of disaster, of crop failure.
Okay, thanks, Alfons. So let's go to James.
Thanks, Alfons. I think you just answered my question in that last little statement that you made. That I was interested in your thoughts on what the differences between Canadian corn farmers and Australian wheat farmers might be, because on the surface of it, they shouldn't really be that different, because they're both largely unsubsidised and not particularly heavily regulated by policy in terms of nitrogen use. Mostly operating sort of in the free market, which is different to the US and China and United States of America. But maybe you just answered it with and Graham alluded to it as well, with the negative response from excessive nitrogen, which doesn't appear to be in that graph. Any other thoughts?
Oh, sorry, I meant to say, so with Graham, one of the things that we talked about in the first paper is the need for a range of nitrogen rates at experimental sites in order to get that coming back, where it actually, excessive nitrogen does have an impact negative impact on yields. And too often the recommended rate might be 200 and they go to 225. But if you go to 250, which is not unusual, you will see some negative impacts. And so having a range of nitrogen rates in order to get a more accurate sense of that response function is one of the recommendations that came out of that first paper.
And sorry to jump in, Dave, but just on that, it's interesting because my perception is that growers think at the top of that curve, between the linear phase and the tipping over phase, that they almost think that's a triangle. But it's actually quite a wide band, and it's much wider than they give credit for, in my view. So I think informing that could assist us better parameterize uncertainty.
Yeah, and I would suggest that in the case of corn farmers, it's the opposite. They don't think it's a point. They think it's a very wide band, and I think much wider than what than reality. Because many of the response functions are either quadratic plateau or linear plateau.
Okay, thank you. I'm sorry, Adam, I'd missed a comment of yours in the chat, but maybe you can ask it now.
Oh yeah, sure, thanks. I mean, the comment was just about the downside risk and skewness, but my question was, so I think the result is that sort of risk doesn't really influence the like the application decision in a sense. So but there's still like a cost to risk in a sense. So, you know, like the difference between the average return and the certainty equivalent. So is there more of a case to focus research on just sort of raising average profitability and lowering risk in that sense if the sort of risk attitude doesn't really matter and that application decision doesn't change with risk? So any sort of special technologies that could do that?
Yeah, I think you know, ultimately with many of these issues, there's technological improvements that solve it. And I think there's two things. One is that hardier varieties, and that's one of the things we've experienced here. You know, the varieties not only have increased average yield, but that they seem to be just more tolerant, and I think that has influenced decisions as well about rate. The other one is if you had, in terms of fertilizer management, they've talked about 4 R's: right rate, right time, right place, right type. And I think the time is one that gets at the effect of weather. So you apply a bit at planting to get the crop growing, and then you apply at least one other time, maybe even a third time in the growing season, depending on what the weather looks, how the growing conditions. And I think matching the nitrogen rate to the growing conditions is one where that will allow farmers to more accurately tailor the rate to the growing conditions, because, you know, as you said, the significant temporal variability through the year. So either that, or else get a better crystal ball of what it's going to be like during the year.
Yeah, rate splitting helps you avoid some of the risk, doesn't it?
Yeah, it does.
So with all these things, it's about the numbers, and one of the few people that's actually looked at the numbers closely in Australia is Marta, and I see Marta's got her hand up.
I was actually not going. I was still gonna make a comment related to the difference between Canada and Australia. My understanding from particularly comments from by Victor Sadras around his work, it's really all about the interaction between nitrogen and water. So it's the nitrogen use efficiency and the water use efficiency in these very marginal environments is particularly relevant. So that would be a big difference as well, apart from other things like subsidies, like other things that have been mentioned. So that's what I wanted to say. Anyway, another thing, I am in Bangladesh at the moment, South Bangladesh, and I will have to duck off very soon. We are traveling, so I can't hold up a whole group of people. I'm very sorry. So I'm just here for a very short period of time. But very nice to hear it, and I probably don't have time to make many more comments about the analysis. I mean, from my work, what was I would say the main conclusion would have been that the probability of making a gain was in a probabilistic analysis was higher than the probability of having a big loss. So that was, I think, one of the highlights that came out of our work. We also did, by zone, there were other learnings from that work, but yeah.
So sorry, Marta, you found the same thing.
Yeah, it sounds like the same thing. Yeah.
Yeah. Yes, it's the same thing. Yes, exactly. Except the environment is different. So the
Yeah.
yes, so the losses would be bigger here, I suppose, because of the marginality of this environment, I suppose. So we probably
James,
have a big weight than for in your situation.
James has a comment in the chat that the range of yields was twofold in Alfons's graph, but it would be 5 to 7-fold in many Australian environments.
Yeah. So exactly, the impact will be bigger. Yeah, exactly.
Yeah.
All right, let's go to Peter Heyman.
Yeah, thanks. So, I guess just a quick comment is that it'll be interesting to look at some of the work done in sugar in Australia, where people have talked about insurance and so on, and that's probably where the problem is, over fertilizing, and the farmers there are concerned about the regulation there. Or even Peter Cornish worked from wheat farmers and then worked with vegetable farmers, and that they're all about exactly the same thing of over applying because they're worried about that side. I guess my question is just about there's a lot of discussion in Australia about carryover of nitrogen. So where farmers have put that extra 50 kilograms on, in your assumption is that's all lost. It's a cost in that season. If any of that's carried forward, how does that influence the results?
Yeah, none is carried forward here. So phosphorus and potash are, but not nitrogen. So they do some spring soil tests to determine, but no, farmers in the prairies do apply fertilizer in the fall, and they're not worried about loss. But in our conditions with snowfall and melt and lots of moisture, it goes away. So
Okay.
Yeah, I think Dave there, Vonk did some work that showed that at least 22% is carried over in subsequent years from long-term trials using isotope work for wheat.
Before I get to Rick, just to follow up on Peter's comment about work that's been done for sugar, there's a report came out in 2020 by Peter Thorburn and others called, where is it? Innovative Economic Levers, a System for Underwriting Risk of Practice Change in Cane Farming. So this was something that was done for the Reef and Rainforest Research Centre in Cairns. So someone has looked at that issue of trying to sort of underwrite losses of profit as a result of reducing rates as a way of trying to help the reef.
Yeah, I think it was John Kandulu who did that economic analysis.
Was it? He's not mentioned as a co-author on this report.
Yeah, that insurance scheme, I think they made their first payout last season, actually. So it's a little bit closer to a pilot, which is good. Great to have you on board, Alfons. Thanks for joining the RiskWi's team.
Hey, Rick. Nice to see you again.
My question was around, I thought Peter might have asked it actually, is the graph that we just had on the screen before showing the various different seasons with different curves. So a lot of the uncertainty of outcomes essentially comes down to deciding what curve you might be on for that particular season.
Yeah.
And do you think Canadian farmers have some advantage in deciding what curve they might be on, whereas Australians don't have a lot of certainty early in the season when they have to make these nitrogen decisions?
I don't know. I don't. I think we've got less, but I don't think any. And we just look at we're talking about global warming. We've had the coldest July and August we've had in 35 years, with double the amount of rainfall. Yeah, I think we don't have the extent, but the extent of the variation. But I don't think they're. No, I think they know better at weather forecasting and knowing what it's going to be. And again, I think the split application is one way that they can adjust during the season to what they see coming ahead.
All right. Thanks, Alfons. I'm just conscious of time. I just one final question, and then the agenda that Brendan's given me's got a question around what this means for RiskWi's moving forward. So maybe we can spend 5 minutes talking about that. But before that, I just note that James has got a point of clarification in the chat. Were the experiments that the paper's based on done on the same piece of land repeatedly, or moved from year to year?
So the first paper that it talked about, it was done at 7 different sites, data that and for different time periods. The one where the graphs appear is from the Elora research station. Elora is a town north of Guelph, and that's where all the research farms are. It's a long-term trial, and it's corn on corn on corn, and it's same management system, but you know, it no longer is corn on corn a typical rotation. It's a corn soybean rotation and sometimes wheat. So it is consistent over time, but it doesn't really reflect the typical rotation that we're seeing now in Ontario.
So any carryover would actually be implicit in that.
If there was any, it'd be there. Yeah,
I don't think we have to. But there is no real carryover. It's something we just don't even look at now. I thought it might be, but no, it's no nitrogen carryover. It's not worth looking at. Yeah.
And likewise, deficits will compound. So you'll end up with the negative, well, the treatments that have very low yields due to nitrogen deficiency will be much lower than if the site's moved around.
Mm-hmm.
True.
You could look at a correlation between how the following year's y-axis started, that point.
Oh yeah.
And the excess nitrogen. So you could actually test that.
Yeah.
All right. So we may have covered everything that we feel we need to in terms of what this means for RiskWi's, but I'd like, maybe I'll throw it to Rick or Brendan or Lindsay if they have any thoughts on what, or Graham for that matter, what this might mean for RiskWi's.
Well, I guess the obvious question is whether it's worth doing more of similar analyses here in Australia with the range of data sets. That's a question more than what it actually means at this stage. The other aspect, I think, is looking a bit more closely about whether it's a profit maximising or utility max, whatever you want to call it, Alfons, is close to the yield maximising rate for N. I think that didn't quite look at that in much detail, but that becomes quite important, I think, in the level of analyses that we conduct. In the MARTA study that you referred to, Dave, they were often very close. Profit maximising N rate was very, very close to yield maximising in almost all cases, actually.
Mm-hmm.
Yeah.
Mm-hmm.
Any thoughts, Lindsay?
One of the thoughts I was buzzing through my head was thinking about how we would apply the same sort of approach, but thinking about these end strategy experiments being done across the country, and we've got multi-year aspects to them. And so if you apply the multi-year strategy, where we do get carryover in some environments and not in others, how those curvatures look. So that's what I was thinking about. So if you apply a multi-year lens over it, whether that changes those risk return front shapes or not. That's what I was thinking about, Dave. I'm not sure that's a prospective thing or not, but that's what I was thinking through. James is probably thinking the same thing, maybe, I don't know. But
well, yeah, I was, but it's because they're different experiments where you have to think carefully about it, because the experiments we've got aren't a fixed rate every year. They're testing decisions. And so the rate applied every year varies. But what you can do is look at a mean rate over 5 years, because that decision system has come up with has delivered a mean rate over 5 years, and do the analysis based on that. But you can't do it within years necessarily, because it's confounded.
Yeah, to get those graphs that Alfons have, you've got to have a range of rates each year.
Yeah, we've got a range of rates each year, but they're not in the same plots each year. So
I see. Okay.
Like our yield profit type treatments apply lots of nitrogen in positive years where it looks like it's going to be high yield, and apply none when it looks like it's going to be low yield, because they're trying to manage seasonal climate variability.
Yeah.
So yeah, we don't have consistent rates from year to year, except in the national average treatment.
Yeah. Graham?
Sorry, going back, that just reminded, in response to your question, Rick, about a prospect, like I think my sense is that at least in Western Canada, it's based on soil moisture at planting time is a very huge indicator what going forward. Here, we had an extremely dry April and May, and so you would have thought, so there's no correlation about what moisture is like at planting time as an indication going forward in the year. Whereas I think that is a case for you guys.
Graham, is your hand up?
Yes, I was thinking about what James said, and I'm not sure that you really need the same rate year in, year out. If you have the y-intersect and you get the plateau, you can determine the slope.
Or estimate it at least, yeah.
Yes, yeah, with a certain amount of error, which we can do. So one of the things that we're trying to understand is, well, the variation on the y-intersect creates uncertainty. The slope itself up to maximum yield, y max, creates a certain amount of uncertainty. And we're trying to better inform those two parameters, and then how long, if you like, or how wide is the plateau before we start to get some negative effects. So I was thinking that we probably, and James would know better than me, but I think we'll probably have a data set to be able to do that. The other thing is that along the lines of what Alfons has done, I think we should explore possibly accessing industry data, whether it be with a commercial company or other data sets that exist, to try and help augment the data that RiskWi is bringing to apply a similar thinking to what Alfons has provided here. And then if we do sort of a climate risk, a nitrogen response risk with all the parameters, and then a price risk, we can really start to say, like, even some of the really simple messages I think could be valuable, right? In your environment, if you apply 50 kilos of N, you'll never get it wrong. Things like that. I know it's well under what might be required, right, for optimum yield, but you know what I mean? Like, there's a minimum amount you can apply for a response that will never get it wrong, right? And so even that for some of the population out there could be useful. Yeah. I'll leave it there, I think.
All right, maybe that's a good place for us to wrap up. Graham, thank you for that. So I might hand back to Brendan to hear about if we've got plans for a follow-up.
Thanks, Alfons, and thanks, Dave. One quick thought that I had putting my social science hat on was we talked about the triangle and the flatness of the curve. If we've got focus paddocks everywhere, it might be interesting to actually track the farmer and get them to estimate a response curve in a particular season. And then we've got focus paddock and yield profit, and we could actually see how close are they in terms of actually visualizing that. Just as like a little side project, if we're already doing focus paddocks, that might be a neat little thing to compare farmer perception of plateau versus otherwise. Thanks again, Alfons and Dave there. Really great, and I think a really great discussion. Multiple people asking lots of different questions. So really think, Alfons, it's getting late in the evening there as well, but taking the time to come and chat with us as well. In terms of where we're going next, I think we're trying to put together either a participatory action paper or a behavioural science paper to bring a different theme to the risk discussion on our next one. So you'll hear from us soon about what we're arranging there. And I think in the spirit of keeping to our exact hour limit on our RiskWi's reading, well done Adam last time and Alfons this time, we all get 3 minutes to go to the toilet or get a coffee before our next webinar obviously starts somewhere else. Thank you everybody for joining. Thank you again, Alfons, and look forward for everybody joining for our next one. Bye-bye.
And before you take off, Brendan, I really support that idea of getting farmers to guess their nil yield, what N they need to get to maximum. That's a great idea, actually, and where they think the extra N would tip them over. It's perception versus reality would be fantastic.
Yeah.
There's actually very little of that evidence out there now. There's a little bit in the US. I'm aware of one paper, and the farmers were wildly wrong.
Excellent. I love it when I have a good idea. Let's end on that note.
Yeah,
Yeah, that's a great idea.
Thanks, everyone. Thanks a lot, Alfons.
Thank you.
You're welcome. Thank you, guys.
See you,
All the
mate.
best.
Yeah.